Hi, I'm Pat Martino from the Chemistry Department here at Bucknell.
Hi, I'm David Rovnyak, and I'm also at the Chemistry Department at Bucknell.
Sharing science with the public is really important to us. And so you might recognize Dave and I if you've ever attended one of our Halloween chemistry shows that we and the Bucknell chemistry students host for the public every single year. And you might recognize me as Science Pat if you've ever been to the Lewisburg Children's Museum.
So why do we like to create 30-foot fireballs, launch a trash can as high as the nearest building, or create the indelible image of a puking pumpkin? Well, first of all, these things are fun, so do we really need any other reason? But actually, there might be something to seeing and feeling these phenomena. And yes, if you were in the front rows of our shows, you probably felt those fireballs.
So we're here to convince you that live science matters, now more than ever. And just remember, Dave and I, we're trained professionals. So any of the demonstrations that you see here, don't try them at home.
One of our favorite parts of a good demo is usually there's a surprising element. We may see something that we're not expecting. So instinctively, we start to ask questions. So for example, we see this flame burning with a little bit of green, and it will actually get greener as we keep going. And we might wonder, what is the reason for that color? And we see that the powder is green, so maybe there's a connection there. So let's do more experiments. Let's evaluate our hypothesis. Let's look at another powder. Notice the nice green color with that powder as well. But that powder started off a little more blue. How about this powder? This powder, that's one of the harder ones to see, but you'll start to see a purple color develop. Look at the brilliant red of this powder. And sometimes, because we can, we mix them together and we see all of the colors at once. Instinctively, we're evaluating our hypothesis and thinking about these processes. And in fact, if it's not the color of the powder, it's something else, and in fact, it's the type of metal that we're using here. And so what a live demonstration does is it invites the audience into the scientific process, and in fact, it transforms them into scientists.
Live science is one of the single best ways to excite and engage children of all ages into learning. An elementary teacher once shared with us that all children at a young age love science. The mystery is why they stop. So how do we keep these kids engaged and keep them interested in science? Well, we feel it's by doing more live science. We think live science helps to create a wonder and natural curiosity about the world around you. So take these boo bubbles here. Children are always fascinated by the way they can hold these bubbles, they can toss them up into the air, and they don't end up breaking. And so children will start to ask themselves, what's responsible for those properties? And at that point, they're hooked. Now, there's another demonstration that we like to do with a stronger connection to a more serious societal challenge, and that's climate change. We know that increasing carbon dioxide levels is driving climate change and leading to serious environmental impacts all over the world, particularly with our oceans. All of this CO2 is finding its way into the water of our oceans, lowering the pH and driving out oxygen, causing all sorts of problems. So using live science, how can we get the public to care about this issue? Well, what if I told you that the pH of this water in this beaker of water and dry ice is acidic? Would you believe me? Why should you? Many people are skeptical about scientific claims nowadays. So as a scientist, how can I prove to you that the pH of that water is acidic and that's a problem? Well, if I take some of this indicator solution here, universal indicator, which will quite literally indicate the pH of a solution, and I add it to that beaker of water and give it a nice stir, we see that it's a green color indicating a neutral pH, as you know water is. But if I add some carbon dioxide to that beaker of water with indicator, we start to see a color change, going from green to yellow and ultimately to orange and red. So you can visually see that the pH is changing, and you can more readily accept the fact that carbon dioxide is responsible for it, and yeah, that's a problem for our oceans. So what a great starting point for kids to do even more pH experiments.
Fire is very relatable and very compelling. And so, for example, let's see what happens when I blow a little bit of this powder through the flame. Nice. That was a great example of fire. And when we talk about fire, what we really mean is combustion, a very important type of chemical reaction that involves a fuel, like this powder, and the oxygen in the air all around us. And the possibilities with fire and combustion are endless. For example, let's look at masks for a moment, a very hot topic today. Let's see what happens if we try to do the same experiment with a mask on. And just like that, what an outcome. We start to understand just how effective masks are at filtering the air that we breathe. What a difference. So like acidifying water with CO2, we often do experiments that accelerate a process that makes it easier for us to see it. So when we use the powder is very fine, it has a lot of surface area, makes a very fast combustion. But the reason why we look at a fast combustion is that we also have slow combustions. And that's exactly what's happening in you and me right now. The foods that we eat are burning in our bodies, keeping us warm, powering our muscles. And one of the extraordinary aspects of the human body is the ability to slow down this process so that it keeps us warm and keeps us running. We believe that life science is how many people discover their passion to do more. We have serious issues to tackle in climate, energy, and health, and it's vital to feed the STEM pipeline to help solve them. But I'd like to leave you with one further thought, that life science also helps us to see that science is creative, grounded in curiosity, and sometimes we do things to find out safely what happens, as we'll see in just a moment.
Ultimately, demonstrations allow us all to witness scientific phenomena and become active participants in the scientific process. Live science is how we engage the public. We inspire people to feed their curiosity and look for more information, to motivate people to be more science literate and to accept scientific findings. We need good demos. If they're effective in our classrooms, they're bound to be effective in the broader communities. We want to conclude by saying we miss all of you sincerely, and we hope to be able to do live science again with all of you very soon. But in the meantime, if you know anything about Dave and I, then you know we like to finish up with a bang, like showing how clouds form.